Venus is not Earth's twin. It is Earth's warning. In recent years, scientists at NASA and the European Space Agency have returned to a disturbing question. How does a planet almost the same size as Earth become hot enough to melt lead, crush spacecraft, and erase every ocean it may once have possessed? Because Venus may not have started as hell. Some climate models suggest that billions of years ago, Venus may have had clouds, rainfall, and even shallow seas beneath its skies. Today, the surface is hot enough to soften metal, and the pressure is so intense it feels like standing nearly a kilometer beneath Earth's oceans. By the end of this video, you will understand how an entire planet lost control of its climate, and why Venus may be the clearest warning in the solar system. For much of the 20th century, Venus was imagined as paradise. Astronomers could not see through the planet's thick cloud cover. Telescopes revealed only a smooth white sphere glowing in sunlight. Since Venus sits closer to the Sun than Earth, many scientists and science fiction writers imagined a hotter version of our own world, steaming jungles, endless rainstorms, maybe even alien life. And honestly, the comparison made sense. Venus is about 95% of Earth's diameter and roughly 82% of its mass. Gravity there is close enough that your body would barely notice the difference. If Earth were scaled to the size of a basketball, Venus would be only slightly smaller. The two planets formed from similar material in the same region of the solar system. They should have evolved together. But something went catastrophically wrong. And when the first spacecraft finally pierced the clouds in the 1960s, the fantasy collapsed almost instantly. The Soviet Venera missions were built to survive harsh conditions. Nobody expected conditions like these. In 1967, Venera 4 descended through the Venusian atmosphere and discovered something shocking. The air was mostly carbon dioxide, far denser than scientists had predicted. Then came the numbers. About 870 degrees Fahrenheit, across the planet. Not during the day, not near volcanoes, everywhere. Later missions measured surface pressures around 93 times greater than Earth's at sea level. The atmosphere was so heavy that landing on Venus was like descending to the bottom of an ocean. The expectation had been a tropical world. That is not what humanity found. Planetary scientist David Grinspoon later described Venus as the cautionary tale for Earth. Not because the two planets are identical, but because Venus proved that climates can spiral beyond recovery. And then scientists found something even stranger. Venus may once have had oceans. The first major clue came from the atmosphere itself. Venus is wrapped in a carbon dioxide atmosphere so massive that heat cannot easily escape back into space. The result is the most powerful greenhouse effect anywhere in the solar system. But carbon dioxide alone did not explain the deeper mystery. The second clue came from water, or more precisely, the ghost of water. NASA's Pioneer Venus mission discovered unusually high amounts of deuterium in the atmosphere. Deuterium is a heavier form of hydrogen. When water escapes into space, lighter hydrogen escapes faster while deuterium stays behind. What scientists found was like discovering smoke in a burned-out building, a fingerprint of vanished oceans. Some climate models suggest Venus may once have possessed shallow seas or surface water beneath cooler skies. Other studies argue the planet may never have maintained long-term oceans at all. But either way, the evidence points toward a planet that changed dramatically. Scientists believe Venus eventually crossed a runaway greenhouse threshold. As the sun slowly brightened over billions of years, temperatures on Venus increased. If water existed there, it would have evaporated into the atmosphere, and water vapor is itself a powerful greenhouse gas. More heat created more vapor. More vapor trapped more heat. The atmosphere became an engine feeding itself. Eventually, if Venus possessed oceans, most or all of that water may have been lost to space. Without Earth's water-driven carbon cycle, volcanic carbon dioxide continued building in the atmosphere for millions of years. Heat became trapped beneath the clouds like pressure inside a sealed furnace. And Venus did not cool down. It locked itself into catastrophe. But this was not just ancient history. In 2023, researchers analyzing old Magellan radar data announced evidence of ongoing volcanic activity on Venus. The surface may still be changing right now beneath those clouds. Not every scientist agrees on every stage of Venus's evolution. Some models suggest the planet may have become hostile very early in its history. But many climate simulations reach the same conclusion. Once Venus crossed a critical threshold, reversing the process became extraordinarily difficult. The planet did not explode. It suffocated slowly. In March 1982, the Soviet spacecraft Venera 13 landed on the surface of Venus. For 127 minutes, it survived in the most hostile environment humanity had ever reached. The probe transmitted color images of shattered rock beneath a dim yellow-orange sky. No rivers, no oceans, no movement, just heat. Nearly 900 degrees Fahrenheit, pressure strong enough to crush most machines, and still the spacecraft kept working. Inside the lander, cooling systems and electronics struggled against an environment capable of destroying conventional equipment within minutes. Then the transmission stopped. Somewhere on Venus today, Venera 13 still rests exactly where it died. A silent machine sitting beneath clouds of acid and carbon dioxide. That moment changed planetary science. Because Venus stopped being an abstract idea after that. It became real. A world where climate itself had turned against the surface, and for the first time, scientists were forced to confront a disturbing possibility. Habitability is not permanent. Now humanity is preparing to return. NASA's Da Vinci mission plans to descend through the atmosphere directly. Veritas will map the surface in high resolution. The European Space Agency's Envision mission will search for signs of active geology beneath the clouds. But the biggest questions remain unanswered. How long did Venus retain water? Could microbial life have emerged there before the climate collapsed? And where exactly is the boundary between a stable planet and a runaway greenhouse world? Science has faced crises like this before. In the late 20th century, the discovery of dark energy forced astronomers to rethink the evolution of the universe itself. Venus may force us to rethink something equally unsettling: how rare truly habitable worlds might be. Venus is not Earth's twin. Not anymore. It is what happens when a world loses the balance that made it livable. For billions of years, Earth and Venus orbited the same star side by side. One became a planet filled with oceans, forests, and life. The other became a furnace hidden beneath clouds. And the terrifying part is how small the difference may have been. A little more heat, a little more trapped atmosphere, a feedback loop that never stopped. We often imagine planets as permanent things. Venus reminds us they are fragile. Somewhere beneath those yellow clouds is the remains of a world that may once have looked frighteningly familiar.